Hello, everyone. My name is David Leclerc. I'm the host of the ChUG Podcast. I am here with Mr. James Marvin, Camille Stegen, and Lisa Nicholls, who are all directors of, respectively, the flow core at the University of Utah, at McGill, and at Stanford. Thanks for coming, guys.
Thanks for having us.
My pleasure.
Discussion today is on do-it-yourself service and maintenance on the instrument. I recently, in the last few months in my lab, I replaced the laser for the very first time, and then figured out how to fix a machine without doing anything at all, and that saved probably like a good $30,000 of service. And I kind of realized that there's a lack of knowledge in the field on how to do this, that, the other, including in my own lab. We do what we can, but like, and so I thought I'd ask a bunch of people I considered experts in that area. And let's start by quick introduction in strictly terms of like, what do you do with your machine? How do you repair them? And how do you feel about service contracts in general? So do James and Camille, and then we'll finish with Lisa Nicholls.
Yeah, we do as much service as we possibly can. I think when you talk about, every vendor I think is a little different conversation. So BD in particular, in my opinion, you're talking lasers, regulators. It's not too many things that actually break on a regular basis. There's fittings and obviously stuff like that, but so we don't have a single BD instrument under contract, and I think we have 15 BD instruments. Our cell sorters are not under contract. No BD instruments are under contract. Because I think it's like you probably found, if you were able to find the exact same laser that was in your instrument, that can be literally a 10-minute job to replace a laser that has gone out. If you're not replacing power supplies and all that kind of stuff, just swap in, swap out. It's pretty straightforward. So yeah, we try and fix as many things as we possibly can. And service contracts is a much more complicated issue because there's departmental funds that kind of get thrown into it, which is why we do and don't have service contracts in some instruments. But in general, across the board, I don't think in the 25 years that I have been in a flow core would ever spend anywhere close in repairs that I would in service contracts. Not even close.
Yeah.
So if we have 25 instruments right now, that's $500,000 or whatever of service contracts. Like I will never spend anywhere close to that in repairs. Even if I have to pay the vendor to come out and fix things, I'm still not going to spend that much in a year fixing instruments.
Camille, what say you? My joke was, if you were to buy all the service contract, you might as well just buy a new machine every year. Don't bother to fix anything.
Yeah, pretty much. We are out of full service contracts on most of the instruments that are older than 5 years at the core, mainly out of necessity. I just don't have the money and the funds to pay for that many service contract and pay for that much money to companies. It's absurd. It would be way more than mine and my colleagues' salary. If I had like 200K or something like that to spend every year on something, I would hire more staff, not necessarily pay for service contracts. We do have full service contracts on more recent instrument, and that's just because whenever people write grants for new instrumentation as the requirement for Canadian grants, they want us to include in the quote 3 to 5 years usually of service contracts. So whenever PIs buy new instruments to put inside the core facility, 5 years of contracts are included in them. At the end of those 5 years, I expect to know what common issues will happen to those instruments, what will break, how to repair them, because I will have seen the service engineers work on it. So I can guesstimate whether or not it's going to be useful for me to keep those instruments on contract or not. I would also assume that if an instrument needs to be kept on contract because it's so unreliable that I need to pay 50,000 plus a year to pay for a service contract, I probably just need to throw it away because it's just not good and not reliable. So I have the number, and I presented the numbers at one of the last CYTO meetings in terms of how much repairing my own instruments cost me every year versus the cost of service contracts. And between maintenance and occasional repairs, I mean, it's 30% of the cost that I would spend in full service contracts otherwise. So yeah, there's never been a year in the past 14 years where not repairing myself instruments when I could wasn't worth it.
Yeah, that's a nice set of, that's the data you presented at the last CYTO meeting, I think, during the workshop, right? Yeah. Lisa, correct me if I'm wrong, but you actually have a full training in how to repair things due to your past life, more or less. Talk a bit about that and how you bring that to your core.
Yeah, so we worked where we were doing third-party service for mostly the Becton Dickinson, so the BD instruments, not so much the smaller, at the time, the smaller brands. Now things have kind of equilibrated across multiple companies, which is a good thing, right? So certainly there isn't a need to, I think I found, as James did, there's not a need for most of the repairs for BD instruments are pretty straightforward. That's a good thing, or at least on the older style of instruments. The newer style of instruments, I'm going to echo what Camille said, which is, if I have one that really, if I'm keeping your instrument under service contract, you should really consider something about the reliability of your instrument. The other thing that didn't get mentioned, and I think is actually a really important part in making the decision, is redundancy. I mean, it's great to say that, yeah, I can repair my own instrument and I can plop a new laser in 10 minutes, although that can easily turn into a wormhole of 2 to 3 or 4 or 5 days if you kind of get yourself in a kind of stuck. But how much redundancy do you have? Can you afford to be down for a day or two? Can you afford to pre-purchase the parts and have them sitting on the shelf so that when they do go down, you're ready to roll? Because keep in mind, a lot of these parts, we're talking about 6 to 8 week lag times to get them. So all of these things, I think, I don't want to just kind of flippantly say, oh, everybody should be repairing their own instruments. I mean, there's some people that really should barely be putting gas in their cars, never mind doing any maintenance on their cars. So I think you have to balance kind of your personal skills and how much you really feel like getting under the hood is something you're competent and comfortable doing. Parts available and redundancy with the instrumentation. And not just kind of the overall cost, because the cost in experiments is going to far exceed my service contract very, very quickly if I'm throwing away researchers' experiments because my instrument went down and I don't have a way to quickly.
Yeah. Thank you so much. Whenever we talk about do-it-yourself and repairs and maintenance, I feel like we're going to talk about the LSR2, the Fortessa, mostly the BD stuff. Everybody knows them inside out. Anybody who actually gets into the machines will be pretty familiar. Are you guys equally confident opening any platform? Like once you know the Fortessa, you kind of figure you'll realize what's going on with the other instruments, or is there some differences that you've seen with other instruments?
The Cytoflex platform, I think, is pretty basic too. That kind of right side fluidics module. There's pumps that go out, every 1 to 2 years. I think they've upgraded one of those pumps and it's a little bit more robust these days. But if you open that right cover, I mean, I feel like you should feel pretty comfortable getting into and replacing any of those things. And that's the brunt of the instrument. I find it a little annoying. I guess in the beginning, I found it a little annoying that you need this little jig to align the lasers. But for the most part, our lasers, if everything is going okay fluidically, the lasers are actually like pretty stable, and it doesn't seem like there is a whole lot of drift with lasers on that instrument. But so the Cytoflex, I think there's quite a few things that you can kind of get in and avoid having to call somebody in to fix. Similar, actually, I would say with the Aurora.
Right.
A lot of the kind of pressure and fluidic things, a lot of times for us, is just like snapped little kind of fittings that go into that vacuum canister on the front. That's a majority of the things that like pop up on that instrument. Sample lines, some things over there that can be adjusted but or replaced. Yeah, I mean, I feel like with the Aurora, most of it is just kind of like fittings that are just deteriorating quicker than I've ever seen on any other instruments. And so as long as you can get to the fittings and stuff like that, that's gonna keep you going pretty quick.
Yeah, I think I would agree. I think if you're going to go between instrumentation, if you're going to go between analyzer and sorter, even, yes, we're most familiar with BD instruments because they've been around for 2 decades, 3 decades, right? So, and they didn't really change their fluidic base at all, or their electronics, quite frankly. They just changed kind of the shape of the lasers. So I think if you have a really good fundamental understanding of how the plumbing in general should work, right? How is it expected to get the fluid to the flow cell, join that with the sample, and then get down to the waste, kind of that basic pathway in most of the intermediators and how they feed in, then I think that they're all essentially the same inside. And so you just have to be patient enough to kind of get a good look and assume and learn how to dissect the system, right? So learn how to kind of break it into pieces so that you're not trying to evaluate all of the plumbing all at once. You're only evaluating the input or the output. And I think if you kind of take a methodical approach to it, it's pretty easy, even on an instrument you've never seen before, because they fundamentally work the same.
Yeah, I totally agree. At some point, a cytometer is a cytometer, regardless of the company. Of course, if you look at something that works on microfluidics, it's going to be a totally different system than your typical Fortessa, LSR, or Auroras, or things like that. But ultimately, you have lasers, you have an interrogation point in many places, you have some sort of way to carry your particles from one place, there's the sample tube or whatever, to the waste. And if something goes wrong, it's happening somewhere in there. So you just need to figure how. I mean, the first time I started troubleshooting an instrument was a caliber where something was clogged, and at some point, out of desperation, I put food dye in like the sample, or maybe was it the sheet, even just to try to figure out where things are going and where they're clogging. Having like an actual map of the fluidic would have helped, but you do what you have with you, and you'll figure it out at some point, or not. Sometimes you can make things worse. Then you stop and you call for service.
Yeah, not to put anybody on the spot, but the Bigfoot right now is the only one I'm still a bit iffy. Like too many sensors, and whenever something breaks, it's typically a software issue that you go, well, I don't know.
Yeah, I haven't opened any thermo instruments, any attune or things like that. So I'm probably would feel a bit less comfortable working on them. But if necessary, you figure a way.
Yeah. All right. So anybody listening to us might be asking themselves, like, if they do not themselves fix stuff, like, what are the things that you think people are afraid of? Things that you do yourself on a routine basis that you think most people probably do not? Like, I know even alignment has been, it's a lost skills over the years. Like, I used to know that when I first started here at the University of Chicago, and then for a number of years didn't have to do it again, so I had to relearn this stuff not too recently. yeah, so let's talk about that, like the range of things that you're gonna fix on your machines. And where do you draw a line? Where is it like, okay, this stuff I don't know, and I'm gonna call for help at this point?
I draw a line at the electronic boards.
Right.
That's something that if they break, obviously I cannot change that myself. I need proprietary parts most likely. So that's the end of it. The fluidics or anything on the optics bench normally should be fairly easily accessible. I think the easiest for someone who wants to start doing quick fixes would be just yeah, most of the time, if something breaks, it's going to be a fitting somewhere in the fluidics. Like start changing your fittings yourself, your flow restrictors, if they're available. Remember to turn the instrument off before you do that so that nothing is pressurized. Yes, I might have changed a restrictor on a Canto that was still powered. It went well. It was not electrocuted. But yeah, that's probably the part where you're the most comfortable, right? Just changing a few fittings, making sure that things flow, maybe changing sips, O-rings, all those things are fairly easily accessible to people, and they will make your instrument work again, and your users will be able to continue their experiments pretty fast when something goes wrong. Going inside of the lasers and the optic bench when you have no idea what you're doing can feel a little bit more stressful. So I can understand why people would be a bit more reluctant on working on that. But when the choice is between buying your own laser from the company and paying $3,000 or buying the same laser from the instrument company and spending $50,000 on it, well, suddenly you feel way more willing to open the bench and start realigning lasers. So.
Yeah, I don't know. I feel like I would just throw into this caution in the troubleshooting kind of phase of things. I have routinely chased the wrong thing.
Right.
And I think if you do feel comfortable aligning lasers, you can fix all kinds of issues by aligning a laser, but frankly, you're chasing problems and you have some kind of clog, some fluidic issue, some valve that is sticking that is causing some kind of laser delay issues. So I just at the beginning of this, I feel like when you are starting to dive into fixing instruments, take it slow, really make sure that you've done your due diligence, kind of like troubleshooting. When you do have pressure issues, right? Like it can be a compressor, it can be a regulator, it can be all kinds of different things. And so just kind of going through a thoughtful process to diagnose, like, no, I've highlighted this to the sheath regulator, not the compressor, not a leak over here, not a valve over here, and all that kind of stuff.
Yeah, I'll echo kind of what James is saying is very true. I see this a lot when people hop on to the various online forums to discuss problems and, hey, help me troubleshoot this. And I don't hop on those for a reason. It's because it's very difficult to assess in a 160-bit chat where somebody's level is on what their understanding is. So what'll happen is you'll get somebody who really is a very novice, and then you'll get somebody over here who's done quite a lot. And this person over here might have already jumped through all these mental steps and said, oh, I think it's this. But they don't really give this person up here any context of how do they get to that point? What should they have eliminated before they jump in and they start changing the transmission on their car, right? Well, you got a flat tire. So, I mean, so when you do these online chats, I think you run into exactly what James is saying, is that it's really very difficult for somebody who is brand new to know kind of where to start. And the advice you can get just willy-nilly coming in, even on chats where there's a lot of experts, and sometimes because there's a lot of experts, right, is they will just jump ahead and diagnose, and they also don't have all the information, but they've seen something familiar, and that can be difficult because then the person ends up digging. And again, I'm not going to point anything out specific, mostly because I can't remember details, but where somebody's now taken apart this instrument, and at some point you've created far more problems than solved. So I think my advice would be to somebody brand new, one thing, and this is basic science 101, change one variable at a time, right? So if you're trying to align and you think it's an alignment problem with this, and you think you have the horizontal, but maybe it's the vertical, don't do something catastrophic. Don't turn it a lot, turn it just a little bit, just so you can see a bare bit of effect, and then reverse it back to where you are. Maybe don't even change the screw on the mirror. There's springs in there. Maybe just push the mirror. Does it get better? Does it get far worse? Because once you start, I've had those where you go to turn it and all of a sudden the screw that was locking it was under tension and pops, and now the signal's gone, right? And now you're in a panic mode. So I think, going slow, but doing things in a very methodical way. I think you really just have to visualize, what do you think's happening? First of all, cut down the 3 systems. Is it electronics? Is it optics? Is it fluidics? If you can't get that far, then stop. Ask for advice, learn how to narrow down between the 3 systems, then go to the one system, and again, cut it into pieces that are really super manageable. You can only do one thing at a time. And I think then it's much easier to not dig yourself into a hole. And I have gone the other way. I've tried this with computer repairs, which I'm terrible at. And I had laptops that wouldn't go back together and blah, 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 blah. So I get it. Start slow.
Yeah.
I also draw the line with electronic boards. I actually did just try and solder my first electronic board, and it was an epic failure. There's in the Canto cart, there's a little delay timer switch, and I must have just whacked it pulling off tubing off of some fitting, like it's a barb fitting, and I just kind of was yanking tubing off to replace something else. I think I whacked it. Eventually figured out it was this delay switch, and kind of opened it up, and sure enough, you could obviously see this pin was just kind of like separated out from its solder. I was like, oh, I'll give that a try. It was awful. Yeah, electronics, not my forte. But also at the same time, I don't know how many electronic boards I've ever replaced on any of my instruments, again, in 25 years. Like I know it happens, but it is, I think, very rare to have to go in and replace electronic boards.
It happens and it's extremely expensive. And what I would say is we do change things like the influx used to lose the power supplies on the high voltage board, right? And those we would swap out. Now, I personally didn't solder those. I had some help here, and they definitely have done that. They were here in the era when they were building their own cytometers, so they certainly knew how to do that sort of thing. But I think the approach to learning how to do that and do it well is the first time you have a board that needs something where you know what the component is, so you knocked a component loose. Buy the replacement, buy that replacement board at cost from the manufacturer, but fix the one you have, because now you can swap out and see when you did it right? Because it's really easy to overheat the boards, to over solder them, all those sorts of things, which I'm a terrible solderer, but now you have the perfect test case, right? We did this with one of my colleagues, Jonathan. We were shipping each other boards for a troubleshooting problem we were doing where, oh yeah, this part of my influx is working, but this part of yours isn't. So we swapped boards, and hey, swap these out in your machine and see if this works, right? And we weren't even at the same institution, or we shipped them. So if you can do that sort of thing, if you have your own redundancy where you can take an electronic board out and swap it, and it's the same thing, and try it. But again, you have to know a little bit about electronics. You have to know that you can't hot swap electronics, right? Things have to be powered down. You have to be delicate with the cables, reseating, all that sort of stuff. So there's some basic knowledge that's in there that you also have to know on top of the cytometer specific stuff. And to be clear, I was never actually trained as a field service engineer. I'm actually an immunologist. We just happened to do a lot of that service as a company when SciTech was very small. And so we basically bought instruments and figured it out.
Oh.
Right? So none of us had formal BD or anybody else's training on the instrumentation. It was a lot of, hey, get in there and we need to write a service contract and cover these. So we need to know everything about them. So yeah, we were pretty methodical about taking them apart, figuring out how it all works. So it's doable. We did it.
Just to pile on this point about the boards being by the time, and to add to Marvin's comment, James comment, by the time you have to replace the board, there's a likeliness that it might actually be obsolete. And so if you take it out, replace and break it, and now you need to buy a new one, they don't make the ones you had, so you need to replace a whole gang of boards on your instrument. That happened to me once on the MoFlow. Just trying to fix a computer got us a $20,000 repair bill of just all kinds of boards that needed to be replaced. So yeah, take your time on this one. What is in your toolbox? What are the tools that are needed for anybody who's going to be into the fixing machine business?
Good set of Allen wrenches.
I have one of these. It's a nice little pressure gauge. Nice. You can get all kinds of different adapters to fit onto random stuff. I want to have a voltmeter around.
James, before you move on, I think it's important to point out that pressure gauge he's showing you is both liquid and air compatible. So you want to make sure that that's a feature of whatever gauge you end up with.
Yeah, I mean, I could probably, I don't know how editing these ChUG podcast things goes, but I wonder if we could put together a little list of part numbers and stuff like that. I also picked up one of these. I know these are sought after, kind of handy.
How did you get one of these? You found it on the store, or
I'm not allowed to say how I got this. Okay. It's but actually, there's all these. So I went over to the microscopy core, and I just got a box of parts. Like most microscopy cores have everything that you would need to build one of these things. And the jig, there's some smart people that work in cores that do all kinds of 3D printing stuff. Actually, this one was broken, and I just brought it to our machine shop, and I was like, just fix it. And they just, got this piece all fixed. And so between machine shops and 3D printing, there's no reason you can't build something like that.
So
pretty
what
easily.
the microscopy core doesn't have is the right depth lens. Because I remember we tried this a while ago, and you sent me a whole bunch of lenses, and you have to have the right depth of focus for that front lens. The back lens is just a 10x objective. 10x. That's super easy. But that front lens has to have the right depth of focus. Otherwise, it doesn't really matter if it's the right magnification. You're not going to be able to get what you need in focus.
And you think that is pretty rare in a microscopy core?
Well, nothing you sent me in the box worked.
Oh, I have like a whole nother box of those things.
Yeah, I did build a scope out of what you sent, and I did try it, and they never got the correct depth of focus to be able to get, because you can't get in super close. You are there's parts in between where you need to focus on the actual flow channel and where you can actually bring the lens up to. So it has to be the correct kind of range for that lens in order to get there, just like it would be for eyeglasses or whatever. And I'm great with optics, so I can't just name what those numbers are.
But actually, I guarantee you there are replacements for that camera mounts, I think I even bought one. It's a little bit kind of kludgier to have on there, but I've seen all kinds of modern replacements for that thing that mounts on. I mean, I think honestly in a bind, I think I've literally just used my phone and kind of it's, again, holding it in place is a pain in the butt, but there are other ways. Actually, my phone, and I think I used this little jewelry thing. I don't know, it's just a little, anyway, that kind of worked in a bind too. But Allen wrenches,
all the Allen wrenches,
socket set would be nice. Flathead, Phillips. I have a nice set of kind of the smaller screwdrivers that you use for computer, really, really small screws and stuff like that. But nothing crazy, right? I mean,
yeah.
No, and even for the scope, for instance, before 3D printing was easily accessible, I know that way back when on the Purdue list, there were people talking about just using a scope that you can plug on your computer with a USB and a chemistry stand.
Yeah.
And if you move the stand properly, you should be eventually able to get proper focus to look at bead alignment on the flow cell, with the advantage that if you're using a USB linked scope, well, you're looking at your computer and you're not looking at potential glare from the lasers in your eyes. So that can also be pretty sweet. At the same time, I've changed lasers and did some realignment without a scope at all, and just looking at fluorescent beads going through on the screen while moving mirrors around, and it's good enough. Like, it's not something, of course, if you're in a clinical flow core, you probably cannot do any of these things because you need to have something that's way more precise. But for a regular academic core where people like their samples are not necessarily the best prepared the best way to begin with. Even if your CV is at 7% instead of 3% after realignment, it's probably good enough and no one will really be affected in their experiments. So that's fine.
Yeah.
I would say don't use the microscope all that often. You can do a lot with a business card, looking at the spot before and after the flow cell to make sure that it's not getting clipped. Because really, that's really your home run. That's what you're looking for. So a lot of these lasers are getting aligned over very, very large distances. But the angle of incidence coming from one side of the flow cell out the other side should be pretty much parallel to the back of the instrument. So if you have a business card on one side and you have a business card on the other side, you can get pretty damn close. And so then the only question is do you need to walk it back a millimeter or a half a millimeter or forward a half a millimeter? But you don't want to be putting it like this or like this. And so really it's kind of learning to understand that and being able to visualize that. And whether you use a microscope just gives you a single point. So you don't actually know the angle you're coming in. You just know you're hitting where you're supposed to. So I wouldn't say that's even my first tool that I would put in there for somebody who's really just trying to get into it. I think the hex wrenches and the pressure gauge are going to get you a lot further.
Right.
Yeah.
I do have
Go ahead.
No, I have a laser power meter, just like a little wand that you like stick in front of it. I mean, I feel like with gas lasers, that kind of like, God, do you guys remember like doing, what was it, walking, like the big krypton or argon lasers? You had to like walk the optics and all this kind of crap. Like, I feel like all these new solid state lasers are kind of just on and off. But I think sometimes if your sensitivity is decreasing and you're trying to figure out if your laser's losing power or if an optic that's going out or if you have a fiber optic cable that's kind of like deteriorating, it is kind of nice to be able to check laser powers at different points, from the flow cell and just kind of like walk it back all the way to the head of the laser.
But even then, a business card can do the job. If you think that you're losing power or anything, you put a business card, any paper in front of the laser beam, and you can look at whether or not the beam is tight, small, is it getting larger, does it seem as bright as you'd expect? And that's already telling you that, like, yeah, there's something going on with that laser. I have a laser meter, but I've maybe used it once or twice, mainly with one of my UV lasers, to be like, yep, it's crapped, it's dead. But a white paper and looking at the dot on the paper would provide me the same information, to be honest.
It's kind of nice to have a number to give if you're going to call tech support, for example, like just to tell them, hey, this is what I measured. It speeds up things as opposed to the dot on the paper looks like da 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 da.
I do think that the power meter is very important if you're doing fiber delivery. So it is critically important to get that guy dead on with the fiber optics. So this is where you have a laser whose signal to the flow cell is delivered by a fiber optic. So a lot of them are straight just through a series of mirrors, but some of them actually have a fiber coupled to the front of the laser. That goes over to the flow cell. And in that case, it's actually not even necessarily the fiber. The fibers can go bad, especially on the high wavelength or the low wavelength, the high power UV violet. But they also can come out of alignment. And if they're even slightly off, you'll get a serious drop across the course of that fiber optic. So if you have maybe 50 milliwatts coming out of the head, but you only have 20 coming out of the back end of that fiber optic, then you need to align that. And that can be super difficult to do without a laser meter. So that's the one place that I do use a laser meter. I would say outside of that, I almost never use them. I also don't have any fiber optic coupled lasers anymore, thank God. But that's a really, really great use case for what James was describing, being able to measure that.
The other side of that coin is, where do we get parts? And getting parts very often requires some kind of support from the companies. They are very uneven in what they'll do for you nowadays. So yeah, how do you handle getting parts? So do you basically never throw away anything ever? And so basically your dead machines becomes like the life support of the stuff you have. Do you have knowledge of where the companies buy their stuff, and you kind of
I've got some great ideas for some of it. So,
right?
And it depends. And it always depends. So electronics, yes, you're right. That's where our dead instruments, for BD, they didn't change their electronics from the time they went from early Diva instruments all the way out to just about the X20. They were all identical, all of those boards, all those ARIAs, everything. Again, I think somebody's mentioned multiple times, the electronics don't go out a lot, but when they do, there's nothing you can do about it. And if you can swap them out. So if you don't have an old dead instrument and you have one of these older ones, lots of cores have these and they're going to be willing to share these. I have more boards in excess than I will ever use. So yes, there's that. I think the other piece of it is I think somebody talked about lasers. James mentioned you can pretty much buy a lot of those lasers off the shelf. Be careful. Some of the form factors have changed a little bit. So if you have something that's old enough to have a cube laser in it, now you have to have an obus, and where those holes are on those lasers is not the same for actually screwing them onto the, so you can run in some difficulties there. But there's other brands that then you have to just reach out to, so instead of just going generically on the internet and saying, hey, somebody tell me how to change a laser, like, hey, I researched this, I can't get this laser, can I use this one instead? And then maybe give some specific specs, and then maybe an expert in one of the other cores would be able to be more useful to you and say, yeah, that's not really a spec that's going to work for flow cytometry versus it is. For things that are a little bit more proprietary, pumps, all those sorts of things, no, we don't use those. I don't even keep them. We throw them away. They're total garbage.
Yep.
But most of them, you can read the information off the manufacturer and you can figure out the rest of it. And you can order those direct. And then the last thing I was going to say was bizarre things that go bad, right? We melted a bulk injector not too long ago because we had a broken temperature sensor, right? So what does that mean for a sorter? It means you can't pressurize and put your sample on anymore. It's going to be 20,000 from the company. So there are some companies. So Gene Tool is now kind of taking over where SciTech used to do a lot of third-party service and would collect these parts from and store them and then resell them after testing. And now Gene Tool wants to kind of get into that sort of business where they can help you out with getting some parts. So reach out to them. That's an option. I don't know how far they've gotten in that, but that's something that I found out useful. Reach out on the internet and say, hey, Camille, I know that you just decommissioned your ARIA. Do you have an extra? Can I trade you a bulk injector for a blah, 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 That's where these forums, I think, are more useful rather than just putting out there, hey, some random person tell me how to change my whole fluidics board to blah, blah, blah. I think that's where we could be more cohesive. But I think the correct questions have to be pretty directed if you're going to try and get useful help off the internet random.
Yeah, I think a lot of it can be third-party sourced. I'm frankly quite disgusted with BD's current. I don't know if they're just saying this to me, but just recently they have told me that they are no longer going to sell me any service parts. And so I don't know how many years ago, I feel like they did a restructuring of their catalog system and moved some things into this like off limits kind of service only available to service engineers. But it was still, you could kind of get them. You just had to know who to ask, and they would eventually get you a quote for it. And just recently, they said any of your service parts are now going to be required to be. I need to get clarification on this. It seems like it's at least going to just have the mandatory 4 hour travel time or something like that, like built into it, but they're not going to just sell me the part. They're forcing this issue to have somebody come in and replace it if it is a service part.
Right.
And I'm kind of working through that right now. I'm quite disgusted with this move by them. But that is, again, like regulators. Like I like to have those stupid regulators, the sheath and the pressure on the Arias just kind of like go bad. And I like to have a few of those like on hand because it's like a 20-minute swap out. And I feel horrible that I would have to like basically have the instrument down while I kind of arrange the service call and all that kind of stuff for them to come out and do something that I can very, very readily just do myself.
You buy regulators from them?
Yeah. I mean, I thought they were, so this is the weird thing about like what we're talking about. I feel like there is all kinds of opinions and voodoo out there and all that kind of stuff. But I was under the impression that they calibrated those regulators in-house so that if you do just buy it from them, they're essentially like ready to go. Where if you got the regulator from, we're talking about these regulators right here. But if you get them from, what is it, Control Air, I'm not sure they've been kind of tested and kind of like validated for the appropriate pressures. That could be wrong. That could be all electronic-y and you don't, that's a whole nother topic, but
no, you're not 100.
you're telling me you buy these things from like Control Air or whoever?
I do, yeah. But
yeah, that's great. Okay.
But yes, it does mean that I can't plug it in and there is a potential. It's just like you buy your lasers and you don't necessarily know that they have the beam spot where you need it to be. So in general, the waist for OBIS lasers purchased from Coherent is in a usable position for most flow cytometers. That's not always true though, right? So it's the same thing with the regulator. In general, they're pretty close to where they need to be. But keep in mind what you're sending over, the way those things are controlled is via a voltage, and that gives you a certain pressure, right? And so if that is significantly different from the voltage settings kind of range from the one you pulled out of there, that just means you have to go in and do a fluidic calibration, which is a total pain in the butt, but it's certainly a doable operation where you can go into the fluidic module, and then you can read out the pressure, and then you have to do this calibration where you walk it into the correct pressure so that across all the three things, it will be correct for all three of your or four of your nozzles. So it's not quite as plug and play, but it's certainly not a massive undertaking where you would have to do something really radical. And like I said, we're happy to kind of come up with some procedures and help share those. And I think that's a piece of what this is about, right? Is how do we go to get that knowledge, and is there a way to centralize it?
Yeah, that's a good segue. This is the last portion of the discussion I wanted to have. I very much feel like everybody in their own corners know how to do stuff with their own machines, but then none of that is shared. None of that is and then you try to talk about, so it's what should we do to present that in a way that's kind of like the thing I don't want to do is basically yet another training where you get people to travel to someplace to learn something. Nobody can travel anyway, and the second you get people to try to find funds, like you compete with Cyto or some other ABRF meeting, and then suddenly you can't go anywhere. So I just don't think training, like on-site training, is.
I don't know if I totally agree with that.
Okay.
If you can tell your institution that this trip is going to cost me whatever $2,000,
right,
but we're not going to have the $30,000 contracts.
Yeah.
Like, I mean, I've talked to Lisa a couple times about the same thing. Is like, yeah, I feel like you introduced us as like experts in this. I am a hack. I am like a
Right.
complete,
Aren't we
like,
all?
well, no, I think you are not. I don't think you are a hack. Like, I am a hack. And I've figured stuff out kind of, yeah, I mean, my troubleshooting is embarrassing, and I don't even want to kind of like say what the process is sometimes. It involves way too much. Well, like, I'm just gonna unplug this and see what happens.
Right.
It's, there aren't kind of detailed protocols and that kind of stuff. And I would value a place that I could go. I don't know what that would look like as far as instruments and all that kind of stuff, but or the different vendors and all that. But historically, I would very much go to a place that were, expert hacks or experts themselves
Right.
at fixing this kind of stuff. I think that you can save a ton of money, save a ton of downtime and all that kind of stuff. And I think you are right that every institute and the relationship that you have with your administration and kind of the budget folks is probably different. But at least historically, where I have been, University of Chicago, Northwestern, University of Utah, like, I don't think there would be much fight or hassle in kind of getting funds approved for, a couple day class or whatever at some places that were really experts in this. I agree with you that like much of this stuff can be kind of done through better documentation and kind of databases, but there is sometimes no replacement for just kind of sitting down next to somebody and turning wrenches kind of like right with them.
Right.
Yeah, I kind of want to try to do some sort of crash course or something at the next Canadian meeting, just because those are small meetings and it's one of the few occasions where we have a lot of Canadian core managers in the same room. So that can be a good occasion to just share tips and tricks on different machines. But for that, it still means that you need to have access to machines that you can take apart. So if we have something that is decommissioned, for instance, maybe be able to bring it around. I'm lucky in some ways because yeah, pretty much. But at the same time, no one works with those anymore.
I know, but still.
Like an LSR2 would be more fun probably to play around because it looks a little bit more like a Fortessa and other similar instruments, but still, you do with what you have in hand. Being in Montreal, having multiple cores around can help because for us, it's very easy to travel from one core to another if someone is doing something funky that other people wants to learn. We can just say, hey, I'm going to try to do this thing on this day. If you want to see or help, or if you have any ideas, come see me after like 12 or something, and we'll open the machine and we'll play around and try to figure it out. But that's pretty much what we need to do. It needs to be hands-on. It needs to be in a smallish community so that everyone in there has a chance to tinker, has a chance to play with it, has a chance to actually do the thing. The build your own flow cytometer portion of the annual courses were a decent introductions in some ways to for a lot of people. Of course, you work with very basic features, but it helps make people more comfortable with all those different aspects so that they can play around in their lab afterwards. But yeah, it cannot be online. It needs to be hands-on. It needs to be with an instrument that resembles what people will be working with, just so that they have some sense of familiarity, even though if they've never done that before.
Yeah. I think some of it is also a case by case basis. Like we both made the case that hands-on is the way to go. But at the same time, YouTube I don't care if you're working on your motorcycle, your car, your house, your plumbing, your whatever, like there's a YouTube video for it. And those are incredibly helpful. I mean, Dave, I think didn't you drive like an initiative to kind of like send out a, hey, everybody, like videotape or not video, like record
That's
video.
Your
a lot of
camcorder
work.
out. It's
Yeah,
not.
get your
It's really
camcorder
not,
out,
though.
send that VHS to people,
Yeah.
and yeah. But and so there was a number like so the pump replacement on the Cytoflex. I actually did record this video, and I just feel like I don't know, it's not high on my priority list to kind of like go and edit the video and like trim it and kind of I do I just I want to do it right when I kind of like do it, and I would like to kind of like have the troubleshooting of kind of like annotate kind of, oh, before you do this, here's the problem that we were having. Here's how it manifested. Led us to this, and then here's how you actually kind of like replace the pump, and then, um, so I think good quality YouTube videos are like, I mean, I don't know what percentage of common things could be just fixed by watching a good video, but I think a ton of them,
Yeah.
could be done with like good videos. So that initiative is great. I don't know where that is and how many kind of videos you have gotten and kind of uploaded and stuff. Like, yeah. If you want to edit things, I will send you all kinds
No,
of.
yeah. I'll send the invitation again. Like basically anybody tapes any like or records anything that you want to where you explain something how to fix stuff. I'll do the editing to your liking. So far I've not received much of anything. I've basically made most of the stuff, and I tend to not care much about quality. Like if you can present something really to the point and it's pretty quick, it's good enough, and just start there. And like something is better than nothing at this point. It's my angle.
But I think that yes, videos are good when you already have an idea of what you're going up to a certain point. What scares people from trying is really not having someone close to them to help them as they're going through it. I can look at a video on YouTube to like repair my like blender at home or whatever. If I fail, it's fine. I will have to buy a new blender, but like it's only me who'll be missing out, right? As a core, if we try to repair something and we fail, we destroy a bunch of people's experiments. So we also have that added responsibility of making sure that what we're trying to do will work, and we're not going to make things worse because we will affect other people. Which can be scary if you're just trying to change a laser or change a valve or something like that without having done any work but just looking at a video. I haven't sent you anything so far this year because surprisingly this year I've had 0 repairs.
Yep.
It's November.
There you go. There's a problem.
Maybe we've changed. Yeah, we changed a laser on the Aurora, but this one's still on contract. So like it happened, but it happened in like 10 minutes, whatever, it was done. I lubed some O-rings and things like that, but like, yeah, nothing broke. So I had nothing to repair.
I'll say the thing on the YouTube, just to like last thing I'd say before we move forward, you might not be completely like have all the information that you probably need on the YouTube, but at least it will tell you if whether something is possible or not. If you don't see a video on something, probably nobody tried it, and therefore don't try it yourself. And so at least it gives you a range of things that
I mean, there's very few things we would not try ourselves, I think, on the cytometers, right? They're pretty I mean, yeah, I guess I hadn't really gotten in the habit of making videos of myself when I repair them, mostly because I'm busy doing other things. And it's like, Lisa, you need to repair this. Somebody's on it at 10.
Yeah.
And you're running down the hallway to quickly fix whatever the problem is, right? So Yeah, it's an interesting problem because it's also hard to just create problems, right? In order to create a learning process.
Right.
So yeah, I have some kind of malingering issues I could potentially do that sort of thing for, right? Where we've got one plate loader that just goes nuts occasionally. So maybe we should try swapping out some electronics, and maybe we should try swapping out the plate loader. And maybe when we pull that out, we should clean it, blah, blah, blah. So those sorts of things can be planned. But that's like, hey, I'm taking this instrument down for 2 days to do this. And then it makes sense to do videos. The kind of the day-to-day repairs that I think that most people are going to find approachable. Those are the sorts of things you're doing on the fly while you're over here doing the scheduling. You're also over here repairing the instrument, right? So I think that's really the big barrier to creating YouTube videos for most of the things that are going to be useful to 95% of people.
Yeah,
at least
yeah.
from perspective. So.
There's a lot of stuff. Just keeping your instrument clean. There's a lot of, back to James' point about voodoo. Everybody has their little thing about what cleaning products they prefer and blah 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 blah. It's all over the place. So
I will say another along these lines, like frustration. I don't know how there isn't a good database of third-party parts.
right.
Again, I think that like we're talking about not hundreds of different parts. We're talking about, dozens of kind of very routinely high common or highly kind of replaced parts. And I feel like sometimes I just get overwhelmed. Like I'll ask for, it's like sometimes it's fittings and like there's poly this and polyethyl this and polypropyl this and like in this part you use for, your sheath lines and this one you'd want to use for your waistlines and blah, blah, blah. It's not overly complicated. And then you got different barbs. You got your 1/8 inch, you got all these inner outer diameters and all that kind of stuff. And I think some of these catalogs are like, I don't know, they just take a lot of time to sift through. And I just get frustrated sometimes. I'm just like, give me a part number and I will go order the stupid thing. I don't want to have to like, sift through a bunch of people just send, oh, this vendor has it. And it's just like, well, they have also 7 million other things that look very, very close to the thing that I'm getting. And I think for folks getting into this to eliminate that kind of chaos from having confidence that they're ordering the right part would be nice. If there was just a centralized database where it's just like, here's the part on this particular instrument that you're trying to replace. Here's the vendor. Here's the catalog number. Go buy it.
Yeah.
That would be very helpful, I think, to a lot of people.
I agree. At the same time, I really like to browse through McMaster-Carr's catalog.
I do
It's
not.
my happy place.
Yeah, I hate it. I have better things to do than that. It's a time sink and I hate it.
Yeah, but you go for one fitting and then you're like, oh yeah, I might as well buy another one to have space for that one. And then suddenly it's just like you've lost one afternoon looking at fittings and barb thingies. And no, it's fantastic.
So I reached to Lisa a while back and a whole lot of bunch of people to organize some kind of class, and that went nowhere. But I think my idea right now would be, because like we're going to do a meeting or like not a meeting, like just a class like this, you can expect marginal support from vendors, if any. So it's basically needs to be as cheap as possible. So, so my idea was basically create a framework of a class that you can present like in Chicago or wherever, but then make that available. And so it becomes like an open source course that people in Utah, people in like on the coast, wherever, can just pick up that thing and just adapt it to whatever they're doing, whatever instrument they have available, and then present the class locally. And so I think that would be, instead of having people fly over to where you are, you kind of move the class around to different people. I think that would probably be the better way of.
I mean, I think it depends. If you find somebody, like honestly, if I had space, I would totally kind of like take an instrument down for a day for a class or something like that. I mean, honestly, I think the institution that is hosting it should get some kind of like financial kind of support from the people that are visiting, $100, $200 per person or
Right.
whatever that's coming in, that helps pay for downtime and kind of tech time associated with all of this. I just feel like it's just tight, it's crammed, and I just don't know if that would be the best place to do it. But you might have somebody that has excess instrumentation. We also have a lot of instruments. We have a lot of different things, and they're not all used 110% of the time, right? Like I think without upsetting people, I feel like I could plan ahead, take an instrument down, and kind of we could go over some things.
Yeah.
I have an aria that we, for reasons we won't get into, had a lot of sheaths go in the wrong spot, and we're not repairing it, but it's sitting there in a very large room next to an LSR, which I could take down for an extended period of time, and go through all of that. I think the question really is more about timing, right?
Yeah.
For us, it's crazy busy. So, if this is something people realistically want to do, yeah, I have an aria too that let's strip her down and figure it out, right? There's a couple things that I could get out of that by doing that. And in doing so, maybe this is the time to make a bunch of YouTube videos, right? So basically, saline ran through the whole air system. So let's track down the whole air system and look at all those parts and videotape all that. And here's all the fittings and changing it. And this is what we're going to test and compare those tests to an instrument that's working, which we have in redundancies. So this is definitely and it's in a room that would be very doable for all of this. And again, we could do the same thing with an LSR that's kind of sitting right there. I just got rid of one, actually. We just stripped it down and threw it away. Or discarded the carcass and sort of thing. So it's not that it's not doable. It's just that, is this a format that people would find helpful to have a small group there that in the process of teaching the small group does the videography
Right.
while we're teaching the small group, right? So that it's not, because what I cannot do really is go to multiple, continually,
And travel around
this is
the
already
world.
a full-time job, right?
Yeah.
Yeah.
And so I'd be happy to kind of host that sort of thing, but a lot of it's about timing. So, and to be honest, this is great timing, because coming up on the new year is usually when most cores, I would say, are the slowest, right? Coming out of, everybody's put their cells away for the holidays, and so usually most cores are quite slow. At least ours is super slow in the first month of the year. So, these are definitely possibilities, and I think it'd be interesting to put that out to the community and see if that's something that would be useful.
No, I think people would be stoked, honestly. It would do a great service to the community. But yeah, it's time consuming.
Yeah, sure.
Yeah. So yeah, we would definitely need help with videography. Like I said, we did videos for COVID, and I really did not enjoy the experience in terms of the amount of time it takes to edit them and figure out something intelligent to voice over. And instruments are noisy, so you have to voice over pretty much all of it, and that's fine. But I think it just means a matter of coordinating in a real way. But like I said, I do have that. I do have an LSR and an ARIA if people are interested in that sort of thing. I think that's something that's viable for us right now. I don't have things like Cytoflex, the Curies or Accuries or however you say that. I don't have kind of those things. But...
All right. I think I want to stop here. Any last minute things you want to bring up before I let you go? Cool. I don't know. I think we should work on that. Slowly but surely, we can definitely come up with some kind of presentation or any kind of something to help people out. That feels like a reachable goal. Well, James, Camille, and Lisa, thanks so much for coming. Thanks for our viewers for hanging out with us today. And we'll talk to you later. Cheers.
All right. Thanks, David. It was fun.
Cheers.
Thanks.
Ciao, everyone.